All right, this is lesson number 45, inverse, exponential, and log. This is going to be the last lesson on exponential and logs. We talked about how to solve them, graph them, transformations, all of that jazz. We're just specifically, lastly, talking about inverse. If you haven't known by now, they are inverses of each other. Thought I'd start with a quote for today. Perseverance is the hard work you do after you get tired of doing the hard work you already did. I want you to pause this and think about what that means to you. All right, awesome. So I just thought it was a good quote, had to do with the third goal of never giving up. Just thinking about kind of things from a long-term perspective, like life is a marathon. Like any goals that we have oftentimes are a marathon. There are going to be moments in which you get tired, you get frustrated, and you want to give up, even after seeing all that you have done to get to the point that you are. And just important to remember, perseverance is continuing to say, I'm not going to give up, continuing to work hard after you're already tired from working hard, because ultimately nothing that is worth having, I believe, in life comes easy. All things that are actually worth it are not easy. It also makes me think about one of my favorite quotes, which is posted in my classroom, which is hard work beats talent when talent does not work hard. Hard work beats talent when talent doesn't work hard. Just thought I'd share it with you. All right, we will learn math, build character, never give up, and ask why. All right, today's lesson is actually going to be kind of short. First, let's just kind of review exponential and log. Inverses, just a refresher. This is the graph of an exponential 2 to the power of x because it has the point 1 comma 2. That's the differentiator. It also has the y-intercept 0, 1. Log graph with the base of 2 looks like the red one here. That one has a x-intercept of 1 comma 0 and a point of 2 comma 1. What we should notice is that they are inverses because inverse by definition, x and y flips. So this one has a point 1, 2. This one now is 2, 1. This one had a point 0, 1. This has a point 1, 0. A log and an exponential are inverses of each other. Looking at the domain of the blue graph here, it goes from negative infinity to infinity. That's the domain of, if I'm calling this f of x, the blue one, the exponential. The range of that one, it has an asymptote here, right? And so it starts at 0, 0 not included, and it goes up forever to infinity. If you're looking at the red graph, the domain of the red one, it actually has an asymptote at x equals 0, and then it goes to the right forever. So the domain is 0 to infinity of the inverse. And the range is negative infinity to infinity because it goes down forever and up forever. And so what we should notice, because they are inverses and x and y flips, is that the domain of the original becomes the range of the inverse, right? And the range of the original becomes the domain of the inverse. Just a refresher there, okay? Looking over here, what is the equation of this blue graph here? Okay, it is e to the power of x. Okay, e to the power of x. Because the first point of this one is 1 comma 2.72, right? What's the equation of this one? All right, good. It's ln of x. Because the point here is, oh, not that one, 2.72 comma 1. So they're inverses, right? X and y flips. So just one thing to know, all inverses reflect over this imaginary line right here, right? If you were to fold this one, fold it over that line, it would give you that one. So this imaginary line right here is y equals x. All inverses reflect over that. And then the domain and the range flip, right? That was what we talked about over here. The domain of the original becomes the range of the inverse. That's just a refresher on the graphs of those, okay? But specifically for today, we're looking at the inverse equations, how to find the inverse of the equation. And because we've done a lot of solving, it should be pretty simple. So this right here is the equation of a log. And let's say that the question says to find the inverse. So if you're trying to find the inverse of that, we would be switching x and y because x and y switches. So this right now is another way of saying y. So we're going to switch that to x. So it'd be x equals log base 2 of y plus 2 plus 3. That's when we switch x and y. And then after you switch x and y, then you just solve for y. So we want to get rid of everything on the outside of this log first. The only thing we have on the outside of the log is a plus 3. So we're going to move the 3. So it's going to be x minus 3 equals log base 2 of y plus 2. Okay. Then we're looking, did we get everything on the outside of the log, on that side of the equal sign, away? And it will be yes. So now to get rid of the log, we're going to convert it to exponential, which goes like a circle, right? 2 to the power of that whole thing, x minus 3, equals, we're going to come back around, y plus 2. So we got rid of the log, we converted it to exponential, and then since we are solving for y, we just have to get rid of this 2, so we're going to move the 2 over. Now when you subtract the 2 to the other side, we're not going to subtract it to the exponent. It's on the bottom. So it's 2 to the power x minus 3, the minus 2 out here, equals y. Since we're found the inverse instead of y, we will be using what? Okay, good. F negative 1 of x equals 2 to the power x minus 3 minus 2. So this is the inverse. So the inverse of this log is this equation, which is an exponential. And every time we find the inverse of a log, our inverse should be an exponential because exponential is the inverse of log. Now, how can we check that the answer is true? We can check it by graphing. If we were to graph the first original equation, actually I can switch the slide. So this was our original equation. If we graph that, it gives us this blue one here. And then our inverse equation was this. If you graph that, it gives you the red one here. And so if you were to graph your original one and then you were to graph your inverse one, you can look at it and you could like pick a point. Like let's say I pick this point, 2 comma 1, 2, 3, 4, 5. Is that 5? 1, 2, 3, 4. 2 comma 5. And you can flip that around and that will give you 5 comma 2. And you can see 5 comma 2 is on the other one. So that's a way you could check your work. Or you can visually look at it. I said that weird, visually. Visually look at it and see it reflects over that diagonal line. So that's kind of how you can check your own work. You can graph it, pick a point, flip that point, or you can just graph it and look at it, okay? All right, so let's try another one. Find the inverse. So if we want to find the inverse of this equation, first step, switch x and y. We switched x and y. After we switch x and y, second step, get the log by itself. So is there anything outside of the log we need to get rid of? Yes, we need to move the 4, and we need to move the 2 to get the log by itself. So which one do we move first? The 4. I'm going to subtract 4. Okay. Now, do we have log by itself? No, we have a 2 still. We need to get rid of the 2. How do we get rid of the 2? Divide, because it's being multiplied right now. So it'll be x minus 4 over 2 equals ln of y plus 2. Okay, so now we have log by itself. There's nothing around the log. Now we need to rewrite it in exponential, but remember, this is natural log, ln. So now the base is e. So when we rewrite it as e to the power of x minus 4 over 2 equals, bring the circle back around, y plus 2. We're solving for y, so now all we need to do is just move the 2 over, right? And so it's going to be y equals e to the power x minus 4. Let me actually, I'm running out of space here. Let me move this up here. And let me just go ahead and change that to f negative 1 of x equals e to the power x minus 4 over 2 minus 2. And that is the inverse of that. And it should be the case that if it is a natural log, the inverse of a natural log should be e, because the base is e. You can check your answer by graphing if you would like. All right. Let's try one more. You can pause the video and try it yourself if you like. I know it has a fraction and some of y'all might be afraid of it, but it's okay. You can do it. If you don't want to pause it, you want to see me do one more, I'll do this one, all right? First step, switch x and y. After we switch x and y, then we're looking for, okay, do we have this log by itself? No, we need to move the 4, and we need to move the 1/3. Let's move the 4 first. Add 4. X plus 4 equals 1/3 log of y plus 2. Okay. Now, do we have the log by itself? No, we still have that 1/3 out there. How are we going to get rid of that 1/3? We need to multiply by the reciprocal, 3/1, so that it can cross out. So we need to multiply all this by 3/1. So we can distribute that. It'll give us 3x plus 12 equals log of y plus 2. Okay. Now do we have the log by itself? Yes, we do. So now we can go ahead and rewrite it in exponential. But what is this base right here? Now it's log, it's not ln. So when it's log, the common base is 10. So when we rewrite that, it would be 10 to the power of 3x plus 12 equals y plus 2, right? And then we would just need to move this 2. So we just subtract 2. We're going to get, I'm going to go ahead and change this to f-1 of x, since we found the inverse, equals 10 to the power of 3x plus 12 minus 2. And that is the inverse of that log. Very good. Okay. Let's just talk about going backwards. So let's say your equation was in exponential form. This is an exponential form. And we want to write it from exponential and find the inverse of that. We should already know the inverse of exponential is a log. First step, switch x and y. Okay. We switched x and y. So now we're going to solve for y, right? In order to solve for y, now we need to get this by itself. So we need to move the 2 and we need to move the 4. Let's move the 4 first. Be x plus 4 equals 2 times 3 to the power of y plus 3. Now, do we have this exponent by itself? No, we still have to get rid of the 2. So we need to divide by 2. It's going to be x plus 4 over 2 equals 3 to the power of y plus 3. Now we have the exponential with the base and the exponent by itself. So how are we going to get rid of that now? We need to convert it to log. So if we want to convert that to log, it'll be log base 3, like a circle, of x plus 4 over 2 equals y plus 3. Okay. We're rewriting it into log because it's currently an exponential. Now, we can't mess with this anymore. What's in parentheses is in parentheses. So when we move this 3 over, it's not going to go in parentheses. I'm going to change this to inverse because we found the inverse. It's going to be log base 3 of x plus 4 over 2 with the minus 3 on the outside. And that's going to be our inverse of our exponential that we had there, which we can check by graphing the original, graphing the answer, picking a point, flipping it, or just visually looking at it. Okay? Beautiful. All right, let's try one more. This currently is in exponential or log. Okay, it's in exponential. We're finding the inverse, so we're going to switch x and y. We switch x and y. After we switch x and y, we need to get this by itself, the base and the exponent only. So we need to move the 3. Okay, do we have the base and the exponent by itself? No, we have the 2. Now, one thing to note here, if it was like this, we would convert it to log right away. but this 2 is not as the base. It's in front being multiplied, separate. So we need to get rid of it. So it'd be x minus 3 over 2 equals e to the power of y. Okay? Now, we are at a place here where we have the base and the exponent by itself, and so now we need to rewrite it into log form. So it'd be log, or base e, right? We don't want to do that, though. We don't want log base e. So what's log base e rewritten as? ln of x minus 3 over 2. That's going like a circle, right? ln of that equals y. And look at that. We don't actually have to move anything. We can go ahead and change this to inverse. So that's the inverse of that original. Okay? Now, before you practice, just one thing to note that will probably come up in the practice, which your practice for this one is a quizzes. The difference between these two when you're finding the inverse, just to be careful, because this is things that have come up in previous times I've taught this. When you switch x and y on this one, and you convert this to log, it will be log base 2 of x equals y plus 3, right? Now, when you subtract this 3 right here, again, this x is the only thing that log is being applied to. So when you write it as log base 2 of x minus 3 as the inverse, let me change that to inverse. This can also be written like this, okay? These two are the same. It is understood that the log is only going on the x if you don't have a parentheses, okay? If you have a parentheses on both of them, then it's going on both of them. But if you don't have a parentheses, then it's understood that the parentheses is only on the first one. So if you see it like this, then that really just means that it's on the first one, okay? Unless if you visually see it. So like, let's say on this one, like you switch x and y, and you have to actually move the 3 first. And you get x minus 3 equals 2 to the power y. And then on this one, when you rewrite this in log form, you will get log with the base of 2 of x minus 3. Now the whole thing is in parentheses, right? So in this case, you're not changing that. The whole thing is in log form. But on the left case, the log was only being applied to the x. And so you can have without the parentheses, you might see the answer represented like this. When it's represented like that, and you don't see a parentheses, you can write a parentheses solely on the first one because that's all the log is going for. So that's just something to take note of. When you see it like this, know that the parentheses is only on the first one. If you visually see a parentheses, it's on whatever it is over. The parentheses is around, okay? All right, so that is the notes on inverse of exponential and log. Y'all can do the practice on the quizzes.